As we continue our journey learning about Google Cloud services, we're now going to look at specific sets of services, namely services that are available around compute. Now, for most people, compute on a cloud is infrastructure as a service, or virtual machines that are hosted by some provider. As commercial clouds mature, this really is only a subset of compute services. As we'll see as we drill in and work with these, there are situations for which virtual machines are a perfect fit, but there are other types of compute services that are a better fit for other situations. Platform as a service is a set of services that is called managed compute. And the core difference between PaaS and IaaS is in IaaS, you own the machine. You have full access and you can do whatever you need. But it also means you own the machine. If there's any sort of management or maintenance or patching, you have to do it. PaaS means that some of the management is done by the particular vendor or provider. And a really common business scenario is having something like a website on a PaaS so that common operations like monitoring and possibly backups are done automatically. From a pricing standpoint, PaaS is slightly more expensive than IaaS because you're paying the vendor to do some of the services that could be done by some support staff. So it's a very core choice. Now, in addition to IaaS and PaaS, in compute, there's something new on the block, and that's called containers. This is also called Docker, so we'll be taking a look at that in this section as well. Another way of understanding the resources that are available is through this visualization. And you can see this is how Google organizes the information. So when you're looking through the resources and you look for compute, they talk about App Engine, which is their PaaS solution, Compute Engine, which is their VM solution, and Container Engine, which is their container or Docker solution. We'll be exploring all three of those in subsequent movies in this section. So now let's take a look at the details of working with Google Compute Engine. This is often called GCE, so I'll be referring to it as GCE, Google Compute Engine, and it's a set of services around infrastructure as a service or cloud-hosted virtual machines. So to get started with Google Compute Engine, we're going to use the API web browser console. We've already set up a new Google Cloud project. Always have to put any service inside of a project. We've already enabled billing. To use GCE is required to turn billing on. And then we're going to create a GCE instance or a virtual machine using the console. This will generate a REST request, which is formatted as text. So I'll show you what that looks like, which can be passed programmatically or via script. So in other words, you can start this by just clicking in the console. But if you're using this in a production situation, you usually will have some sort of scripts that you use. And we can look at adding other Google Cloud services as we spin up our instance. And then finally, once our instance is live and available, we will connect to it via SSH, just to show you how to interact with your instance. So here we are in our console with our project that we set up in an earlier movie. And we're going to click on the project to enter that project. And inside of the project, on the left side, you'll see a menu of choices, and we want to go into compute. So we're going to expand compute. And you see we have a number of different services that we can use. And we're going to scroll down to Compute Engine. And inside of Compute Engine, we have a number of different items here. And we're going to start at the top with the most common one, which is a VM instance. So we're going to click on VM instance. And the Google Cloud needs to initialize this project to be able to use this service. So this will just take a little bit of time. And now you can see the initialization has completed. So I'm going to dismiss this dialog box. And whenever you start working with the service using the console, Google is polite in that it explains to you a little bit about the service. And it offers you often the ability to take a quick start. We're going to actually just use the console to create an instance. I'm going to just click refresh. And now we're able to create an instance by filling out the text boxes in this GUI interface. So the first thing is I need to give my instance a name. I'm just going to go with the default of instance 1. Then I need to select a zone. If you're ever unsure with what choices you have, you can just pass your mouse over the question mark and it's going to tell you a little bit more about the particular resource. And you'll see in terms of the zones, I have Asia zones, Europe zones, and US zones. And then I'm going to select a machine type. I'm going to scroll down a little bit here. So the machine type that is set up by default has 1 CPU and 3.75 gigabytes of memory. If I wanted to change that, I can click on Change. And you can see that I have shared core machines, great for testing, and very cheap, almost free, standard machines, and then I have high CPU machines, high memory machines as well. Now, when you're moving into production, it's a common situation that I see that the default machine will be used for prototyping, and then depending on the type of application, the type of machine will just be picked up from here rather than using a machine that's more appropriate to the type of workload. So a tip I have from the real world is when you're moving from a proof of concept to real world, if you have workloads that would benefit from high CPU because they're computationally intense, or high memory because they make extensive use of memory, do some load testing and use the appropriate machine. At this point, we're just going to use the default though. Then we have the opportunity to work with different boot disks. By default, we get this version of Linux, but we can click on Change. We have a number of pre-configured images to choose from, different flavors of Linux. And you might be very surprised to see that the Google Cloud also supports Windows Server. In addition, you have the ability to set the boot disk type. By default, it's a 10 gigabyte standard persistent disk, and you can adjust the size if need be, and it tells you about it over here. If you don't want to use a pre-configured image, you can create your own image, or you can use a snapshot, or you can use an existing disk. We'll learn more about these resources in subsequent movies. Again, we'll just go with the defaults here. The next setting that we're looking at is firewall. So we need to add tags and firewall rules to allow specific traffic. We can allow HTTP, HTTPS, and then we have other management, disk networking access, and security options that we'll go into in subsequent movies. Notice it says your free trial credits, if available, will be used for this instance. When you're getting started, look for that information, because if it doesn't say free trial, you could get billed for this. Then we're going to click Create. But before we do that, actually, I'm going to show you that, as I mentioned in the introduction to this, we have a REST command, which looks like this, and would allow you to programmatically create instances. And you have the API reference here. And we also have command line. And you might remember from previous movies, our friend gcloud. So if we wanted to create an instance using the gcloud command, we would just copy and paste this in a terminal window, and we would be able to programmatically create an instance. But we're just going to use the GUI for right now. We're going to click Create. And now that we can see the status that our instance is being created, we're going to go ahead and minimize this. And here we see our instance 1, created in this zone using this disk, using the default network. Here's the external IP address. And if we want to connect to it, we just click this drop-down button. And we have some options. We can open in the browser window. We can open on a custom port. We can use gcloud, or we can use another SSH client. So we have a number of ways to connect to this. So I'll just go with the top one, open in browser window. And just to test connection, I'll just run a Linux command. And there we are, live connected to our instance. One of the things of note in working with GCE instances is they are blindingly fast. This is a differentiator between the Google Cloud and other vendors. I find that on average, VMs spin up or start in less than a minute, often less than 30 seconds. This is contrasted with other vendors where the VMs will take 5 to 15 or even 20 minutes to start. And this can be significant depending on the type of project that you're working with, particularly if you need resources to be spun up and spun down very quickly, depending on spiky load. Going back to the console, let's take a look at what we can see here about our instance. You can see there we connected to it. We've got some logging and monitoring here. If we click into the instance, we can see again we've got some basic dashboard visualization of metrics here, CPU utilization, network traffic, and disk traffic. If we scroll down, we can see that we can associate tags or metadata with this so that we can manage groups of resources. We've got information about the machine type, CPU, zone, so on and so forth, the disks, SSH keys, permissions, so on and so forth. Now, other activities that we can do from the console with our instance is we can reset or restart our instance, we can stop it, we can clone it, and we can delete it. It's important to understand that you're being charged for both compute and storage on any of the resources in compute. Now, the storage costs, as you'll see, are very, very minimal. But if you were to run, for example, 100 or 1,000 or 10,000 instances, storage costs could add up to some amount that you care about. When you're just testing, you do just want to be complete. And when you're done with the machine, not only stop, generally also delete. So I'm going to go ahead and click Stop, and I'll close this tab. And I'm going to click Refresh and back. And you can see that your instance is stopped. As you're investigating setting up VMs on the Google Cloud, you can set them up manually, as we did in the last movie, or you can use some tools and utilities that are included with the Google Cloud to speed up your deployments and your tests. So one of them is Click to Deploy. So what this does is it creates one or more VMs, and these VMs have applications pre-installed like databases and front-end software on GCE. So you can get the lean stack, the mean stack. So this is things like Mongo and Angular and your libraries for front-end and back-end development pre-configured really fast and ready to start working with on your virtual machines. Also, there's databases like Redis and MongoDB and other databases that are available. I'm going to show you an example of getting WordPress running on GCE instances using the Click to Deploy utility. We're going to click on our project. Now, you would think that because we're spinning up GCE instances, we would look for Click to Deploy under the Compute section. Well, you wouldn't. You'd find it under Deploy and Manage. So if we open that up and we click under Click to Deploy, here we'll see a section. And these are analogous to other cloud vendors' pre-configured images. Probably the most well-known are Amazon AMI images, Amazon Machine images. So they're pre-built virtual machine images. And these are built by the vendors and Google to be optimized to run on the Google Cloud. So you can see there's a number of different selections here from databases and data storage systems like Hadoop to Elasticsearch. But as I mentioned, we're going to go ahead and use WordPress because that's a common situation for a lot of my customers. They want to get a quick and easy WordPress site running on the Google Cloud. So we click Go. And as with the GUI interface that we saw in the previous movie, we have to fill in some of our settings here. So we set the zone, we set the machine type, we set the disk type, and notice we have the option to run here on SSDs. Obviously, if you have a lot more data coming in and out, it's going to be a lot faster, but it's going to cost more. So again, run that pricing calculator as I showed you in an earlier movie to figure out and estimate costs. When you're just testing, probably go with the default settings. And then you have your disk size, and then you're going to have an administrator email. And by default, you're going to have PHP MyAdmin. You have the option to turn on something called Google Cloud Monitoring. We'll talk more about that in subsequent movies. Once you've filled in all the settings, you simply click Deploy WordPress. Now, as the deployment is occurring, you see which version of WordPress. By default, it's deployed to a single compute engine instance with a boot disk and separate data disk for website files. It's creating a deployment. Now, a deployment in the Google Cloud Engine is simply a template. Deployments don't spin up as quickly as plain vanilla GCE instances. And again, for a single instance, it's probably a little bit of overkill. But the idea with a deployment is it can be managed by your DevOps team on site because these templates can be source controlled, checked in, checked out. They can be used in disaster recovery drills. So again, we're kind of having a little bit of overkill showing a deployment for a single WordPress instance, but it's so that you can understand the capabilities once you go into production. It also tells you that it recommends that you're going to install gcloud because as you can work with this in the console, you're probably going to want to work with this using gcloud as well. Then it has links to the WordPress documentation. So now the deployment has completed. So under the Click to Deploy section in the Google Developers Console, you can see that you have a success message. It tells you information about your deployment, and it allows you to connect to your server. So as we did before, we can SSH to our server by clicking on Open in Browser window. So we could work from the command line if we were comfortable with that level of WordPress. However, if we're new to WordPress, it gives us suggested next steps on the bottom here. It tells us to allow HTTP traffic to the server, access PHP MyAdmin, and change your MySQL root password. So you basically have a fully installed instance that you can now work with. Now, interestingly, if we click on deployment, you can see this is our VM instance, and here we have the properties of it. Again, we can SSH into it. So the idea with this is that we're seeing the GUI representation of a template, which can be then, as I said, checked into source control. Now you might wonder, does this show up anywhere in Compute? Because isn't this a VM? So let's go over to Compute, and let's go to Compute Engine and VM instances. And now you'll see we have two instances. We have the original instance that we created in a previous movie, and then we have our WordPress instance. And it's just like any other VM on GCE. The difference is we have software pre-installed on it. We own it. We can install plugins. We can do whatever we want to it. So using Click to Deploy has a couple of advantages in that you don't have to install the software in a standard configuration and one that's optimized to run on the Google Cloud. You can get up and going quicker. And you also get the deployment template, which can be used for enterprise deployments. There are resources associated with GCE services. They center around storage and information. There are things like images, which is a saved version of a virtual machine, snapshots, which is a saved version of a VM at a point in time and can be restored, a disk, which is an OS version or type. And you might remember from a previous movie, it can be flavors of Linux or even Windows Server. There is also information that is groups or metadata. It's useful to understand the scope of these resources. So here we are inside of our console again. And before we look at the resources available with Compute Engine, let's be reminded of how the resources are physically set up on the Google Cloud. And this is something we saw in an earlier movie, but this shows us a representation of the physical locations of where the servers and the connectivity is. So we have zones and regions. So notice we have 3 regions, and then we have zones within the region. And this matters in terms of the resource scope. Some of the resources are scoped more broadly, and some of them are more narrowly. Very specifically, Google has some useful documentation in the overview of compute. So I'm just going to drill down. I'm not going to read this to you, but I'm going to give you the high level. Basically, we have 3 different scopes of resource. We have global, we have regional, and we have per zone. In actuality, there's 4 scopes because there's all the way down to an individual instance. So I'll just give you a couple of highlights here. Global resources are available within any zone in the same project. Remember, project is always the top level scope, so it's within a project. Drilling in, regional resources are accessible within a region for a project, and zone resources are accessible within a zone of a region in a project. And then, as I said, very specifically, instance resources are related to that instance. Sound confusing? It is a little bit. So let's go over to the console and let's look at some of the resources and talk about how they associate to our instances, and I think it'll be clearer. So if you take a look, we have 2 instances, 2 VMs, if you will. So you can see we've got the first instance right here, and it's sleeping or paused. So if I click on it, I could start it if I wanted to. So let me go ahead and start it. Reminds me I'm going to get billed, so that's okay. And then I'm going to go back to the main console. And you remember from previous movie that I basically stopped it. And that's a great thing to do when you're testing. You won't be charged for the compute, which is the most expensive part of running a VM on the Google Cloud. And expensive is in quotes here. This is in the pennies or dollars per hour. It's very, very cheap. So now we've got these 2 VMs running. Notice that the VMs are in a zone, both the same zone. And I'm going to actually just minimize this over here. And they have disks associated with them. You might remember from a previous movie when we did the Click to Deploy that WordPress has 2 different disks, whereas the default has 1 disk. And it shows what's using the particular disk. We've got the WordPress service running here. We also have IP addresses, so we have external IP addresses so that we can communicate with our instances. So now if we drill in to Compute Engine and scroll down, we can see that we've got objects around metadata like instance groups. And indeed, we have instance groups set up because, as I said, when you use Click to Deploy, there's a deployment template that's created. Now, another thing that's created is something called a deployment coordinator so that your DevOps team can then manage your deployment. So, for example, you chose to have 100 WordPress sites, maybe with different parameters. They could be run through the deployment here. This is basically a grouping of VMs, if you will. And then underneath that, we have instance templates. Now here, this allows us to describe an instance. This would be for a customized VM that we would make. And again, we would want to put into our own deployment rather than one from Google. And we don't have any of these right now because ours was just a default instance. It didn't have a template associated to it. We go into disks. You can see, as shown on the top console, we've got 3 disks. Do you know why we have 3? Do you remember that WordPress set up with 2 disks? One for data and one for running the front end of WordPress. Again, we can see more information about these disks if we drill into them. We can see what type of disk, where it's associated. And this is the scoping, which zone, who's using it, and information about the disk itself. Now, if we tried to delete this, it would fail because the disk is in use with the virtual machine. In order to get rid of this disk, we would have to go back to the virtual machine and we would have to turn it off and or delete it. So let's do that. It says, are you sure you want to delete this? Let's go over to disks. So you still have the disk available. Now, why would you want to have a disk from an instance that was deleted? Because you could create a new compute instance and attach this disk. This is the thinking behind not deleting the disk. So it's important to understand when you're testing, because you can get your Cloud Console littered with instances and disks, that these resources are considered separately. Again, the billing is not going to be substantial because it's a pretty cheap cost. It's confusing to some people, so I like to demonstrate it. Now, a different kind of a disk is a snapshot. A snapshot is just a point in time. So if I want to create a snapshot, I just click Create Snapshot, and then I say Testing, and I select a disk. And notice I could snapshot that disk. Now, instance 1, it's not active, so it's not really exciting here, but I could go ahead and I could snapshot that. Then I have the option of applying encryption, and I can click Create. So what's interesting about this is you basically got point-in-time restore. So I'm doing this all manually, but of course you can automate any of these processes with scripts and or programmatically. So you really do have the standard management capabilities around virtual machines in the Google Compute Services. While this is creating, I'll go ahead and look at some other objects inside of Compute Engine. So you have image. So you might wonder, what is image? Well, as soon as I bring it up, let me minimize this, it'll be clear. Image is basically your core files or disks with your operating systems installed on them. So you might remember from an earlier movie, when we used this graphical interface to create a virtual machine, we basically were presented with this list of images. And this, of course, would be where you would put your own custom image if you had some custom version of the operating system that you wanted to make available to your organization. You just click New Image, and then you'd have to follow the image creation directions in the source code. And you would basically just upload. And notice you can upload either a disk or a cloud storage object. So this is the cloud file system. Now the networking information is being moved to a different section called networks. So I'm going to skip over that for right now and show that in a later movie. And the rest of the information on Compute Engine is around information and management. So we have objects like metadata, and these are tags basically. And this is a common best practice around cloud resource management where you will edit metadata or add metadata. So in here, if you add an item, you add a key value, and we might say demo, and then we might say California, so that I can remember when and where this was created, and then I can work with my resources based on tags. It's a best practice. It's just as easy as that. And then we have health checks, and this can send automatic requests to a VM to make sure that it's healthy. And we have zones. This shows us our maintenance windows that are scheduled by Google in the zones. The next thing is operations. These are operations that have been done by you or that are being done by Google automatically when you create an instance. So you can see it's a type of a log, basically. The next section is quotas. And this is useful when you are testing and you want to do some load testing in advance of going to production. You can see what are your limits, and if you have some high-volume project, you can work with Google to change the sizes because these are just, on a trial account, kind of really small limits, but they're easily changeable. And then the last part here is settings, which allows you to export your daily usage into a CSV file. And this is often used by my enterprise customers who have somebody from the finance department who is overseeing the cloud spend. So it's kind of a hidden location, so I wanted to point it out. So in terms of the scoping, it's not clear by looking at the objects what's scoped where, and that's why I wanted to include this documentation, because if I scroll back up, it actually tells you which resources are scoped to which level. And I have found this to be a very useful piece of documentation when I'm trying to set up GCE in production. So in addition to using Google Cloud Services Compute virtual machines, there are other services around compute, and those center around Google App Engine. all aspects of App Engine are considered PaaS, or Platform as a Service. And what that means is that you are paying Google to make sure that your application scales properly and has other aspects of management taken care of so that your team doesn't have to. And the core product is called Google App Engine. Now, another flavor of this is something called a cloud endpoint, and this is available on App Engine. The difference is this is a set of business functionality hosted on partially managed VMs that does not have a user interface. So inside of the console, under Compute, I'm going to open that up and open up App Engine, and you'll see that there are a number of objects underneath there, like we saw in Compute Engine. Now, what I've done so that we can understand how to work with the console is I've deployed a very simple Hello World website in Python. Later in this course, we'll be working with both Python and Java, and I'll show you the code that you use to actually create these types of applications that can be run on App Engine. But for right now, we'll just look at one that I've already deployed. So inside of here, I'm going to click on the dashboard, and you're going to see that I have one instance. And as with Compute Engine virtual machines, you're able to see some information about your running instance. Now, it's different than Compute Engine. You can see the number of instances, the latency, and again, the reason for this is you might remember the default for services running on the Google Cloud is to auto-scale. And this is a great reason to put something like a website on the Google Cloud, particularly if you're expecting spiky or unpredictable traffic. You have information about your billing status, your current load, if there are any errors as well. So you can also change the monitoring window over here. And if you have different versions of your particular application, you'll see it here. Now, it's assigned a default URL, and it's a URL with AppSpot. And if you want to take a look at it, you just click right over here. And of course, you could map that to a custom domain name if you owned it. And there's just a Hello World apps. It's a really simple application. Now, other aspects of monitoring a deployed application in Google App Engine are listed below. So you have things like instances. And in this case, we have only one instance. So we're going to have one instance listed here. And you can see how long it's been running. And you also have logs. These are very similar to your web logs. And then you have versions. And this can be used for traffic splitting, as it says. And then you have other utilities related to management. Things like security scans, quota details, caching, search, and then I like to always call out settings because there's always interesting capabilities available in the settings area here. So inside of here, you can see how much budget is allocated daily. So you're basically renting the compute on the cloud, information about cookies, refers, activation, and then this is where you would do your domain mapping. So Google itself now actually will register domains. They have a new domain service, or you can use another domain registration provider. So you'd need to register a domain, you'd add it as a custom domain, and then you can map your website in this case. It's a common piece of functionality and not very intuitive to find, so I wanted to point it out here. Another compute capability available on the Google Cloud is something called an endpoint. So endpoint is an implementation of Google App Engine, so a partially managed compute under one or more virtual machines. It's most commonly used with Android development. It has a set of APIs around it that enable infrastructure access to core services like OAuth for authentication, Google Cloud Storage, Mail, and others. The easiest way to take a look at this is through one of the Google Cloud developer samples on GitHub. And it actually shows the integration into one of the client tools that's often used with Android, Android Studio. So before we go over and take a look at this sample, I want to point out that you cannot see Google App Engine endpoints using the Google Developers Console. And there are some services, this is one of them, that you can only access through command line tools or programmatically, or IDEs that have integration like Android Studio. So here I am at GitHub in the Google Cloud Platform samples. I'm looking at a sample called Gradle App Engine Templates, Hello Endpoints. They've done a good job with their documentation here, showing you, if you are an Android developer, how Google App Engine endpoints are native and really easy to work with in Android development. You can see to add this backend or endpoint, you just follow the steps shown in the screenshots here, and you literally click New Module, which is a Google Cloud module or a Google Cloud endpoint. and then you fill in the information. They're calling it a backend here. And then you can integrate with a minimal amount of code into infrastructure available on the Google Cloud. So in addition to compute resources on the Google Cloud that are either partially managed with Google App Engine or fully managed with Google Compute Engine virtual machines, there's a new game in town, and that's called Docker. In essence, Docker is the ability to have virtualization set at the level of an application rather than at the operating system. From a practical point, it allows you to have more instances of an application, so more websites, more databases, without installing an operating system, whether it be Linux or Windows or whichever, over and over and over. Because of this, it allows for scalable applications that can scale up or scale down much more quickly than applications built on traditional virtualization, much more lightweight, and of course, running on the cloud, much cheaper. So it's really taking the entire cloud industry by storm. Now, interestingly, as with many other of the cloud technologies that have been implemented by various vendors, Google itself is one of the primary authors of this technology. There are other open source contributors, but Google has been using this containerized or Docker technology to run their own infrastructure for years. The first place I'd recommend you'd go is to Docker itself. Docker is a set of open source projects and a commercial company. The commercialization is around templates, tools, support, and training. So you can use Docker at its core for free, but many enterprises work with the Docker organization or other companies that support containerized implementations to have enterprise-type support. I like this picture because it really shows in a simple way why so many people are interested in implementing this type of virtualization. In the old or the current world of virtual machines, you can see we have to install a guest OS each time we want to have another instance of an application. In the new world of containers and Docker, it's obvious how much more lightweight our applications can be because you can see there's only one operating system. On top of that, you've got something called the Docker engine, which is a replacement for the hypervisor that's used in virtual machine technology. Now, to get started with this, and I do recommend that you take a look at it, if you go to docs.docker.com, you can see the steps written out very clearly here so that you can install Docker. If you're working with Google Cloud services that support Docker or containers, you'll need to have these prerequisite steps set up. Google has documentation, but I find the documentation at Docker is actually clearer. So you just install Docker, and then you run a software image in a container, or you can look for an image on their public registry, which is called Docker Hub. It's a great way to start. Once you understand a bit more about images, you can create your own image and run it in a container. You can actually take that image and you can register it as a publicly available image on the Docker Hub, or you can just have a local repository. Let's take a look at the Docker Hub registry. And you can see inside of here, it's a search engine for Docker images. A lot of people watching are probably familiar with WordPress. So let's take a look at the WordPress Docker image. One of the most interesting aspects of looking at this is how many people have already downloaded it. 2,400,000 and more have downloaded this Docker image. So clearly there's some momentum here. Now, if we look inside of this, because this is familiar to a lot of people watching, you can see that we have various libraries associated to this. And then we talk about WordPress, and then it tells you how to use the image. And this is one of the beautiful things about Docker. Once you have the image, which is just a text file, it's a standardized format which describes the components that are going to be part of the application virtualization. So in the case of WordPress, of course, we'd have a front end and we'd have a MySQL database. Once you have that text file, that Docker, that container image, and the Docker client, literally you type Docker run and then WordPress and then MySQL, and your WordPress instance is set up. It's really very, very simple. If you want another one, you can just run the other command, or you can actually set the number of instances that you want. And again, you don't install the operating system over and over and over. That's the beauty of working with containerized application virtualization. Now, this technology, in terms of being a commercial offering, is new to all the commercial cloud vendors, even Google. So at the time of this recording, if I go over to the console and I click on Compute, and I go into Container Engine, The two capabilities that they've exposed through the console are both in beta. Those are clusters and the registry. So if you're using this functionality, be sure to check the documentation for the Google Cloud Container Engine service, as this technology is fast emerging. And for the Google Cloud, in order to work with groups of Docker containers, in other words, to group them together and scale them up, scale them down, there is a set of management standards called Kubernetes. When you use Kubernetes, be sure to consult the Google Cloud documentation. So in terms of compute, we've talked about virtual machines and we've talked about Google App Engine. We've also talked about containers. An interesting new component of App Engine is something called a Google App Engine Managed VM. And in order to understand what this is, it's important to consider the strengths and the limitations of the current compute offerings. So let's look at this on a sliding scale. So if you look left to right here, left being you own and manage your virtual machines, that offering is Google Compute Engine or VMs. Of course, if you go up and down on the scale, with the top being you can run certain code, so less programmability, and the bottom meaning you can run any code, any binaries, any type of code you want, more programmability, then GCE is the service where you will have the most control in terms of management and you will have the most control in terms of programmability. Now, on the opposite side of the scale, in the upper right, we've got the platform as a service. Google App Engine, which Google is now calling the sandbox. They're going to limit you in terms of what code you can run because they are providing a significant amount of the management in terms of the performance and the scalability. So the customers have been asking for something in between. And Google's answer is something called Google App Engine Managed VMs, partially managed and partially able to run code that you want to run. So you can think of it as shown here in the middle of Google App Engine Sandbox and Google Compute Engine VMs. So to understand more about Google App Engine Managed VMs, we need to think about what we just learned in the previous set of movies about Docker and containers, because this is a core technology for this new type of offering on the Google Cloud. In fact, using Docker is required. The idea is that the application will be put into a container. Now, there are two different kinds of containers, which the Google documentation also calls runtimes. There's the standard Google containers. So those would be for services that Google itself offers, like data stores and caches and network services. And then there are custom runtimes. These are ones that developers would create, and they would enable custom processing or custom storage and other services that are similar to that. So let me use a practical example so you can understand how customer needs have driven the creation of this new type of services. I did some work with a company that did genomic sequencing as a service, and as part of that, they had to do processing of JPEG or photo files. So they were doing chromographic processing. So in order to do that processing, they wanted to have that processing occur in parallel because they had unbalanced workload. So they wanted to make use of, as I've shown here, background threads, so that when they got a large amount of photos to process, they could distribute that processing over multiple CPU threads. That is a capability that is restricted and not available if you use a partially managed App Engine, for example, type of solution. They did want partial management. They didn't want to go with a full infrastructure because they didn't have DBAs and DevOps people on site. They had biologists. The second thing is the photo processing was in part handled by a third-party set of binaries that was developed at a research university. And again, they were limited in a PaaS solution because they were prevented from being able to install those binaries. So they're a perfect candidate for the managed VMs, which are a new component in the compute offering set of services from the Google Cloud. Google's documentation as of this recording is on the beta version of managed VMs, so be sure to consult the documentation when you implement this feature. This picture, I think, in particular, is useful in understanding the two different flavors of Google App Engine. On the left is the version that we've had for a long period of time. They're now calling it the sandbox. And this is where we can enjoy partially managed application hosting environments but we are restricted to the type of code we can run and the type of operations we can perform. For example, something like doing a file traversal programmatically is prohibited. So if we need functionality such as that, as I was just talking about with the biomedical example, the new set of functionality shown on the right is the managed VM hosting environment. And you can see you've got a VM OS web server, and then you have your packages or runtimes, and it runs with a standard runtime. So again, this is a simplified drawing. Google talks here about the different types of runtimes that you may wish to add, and that's really shown in the diagram as optional packages. Also in this documentation, Google does a pretty good job explaining the feature differences between the core App Engine and the managed VMs. And again, ones that I think are particularly interesting are in managed VMs, you can run background threads, background processes, and third-party binaries. So as we are wrapping up our understanding of compute services, I just want to call out the acronyms because you see them so frequently in the Google documentation, it can be confusing. So GCE is Google Compute Engine, which is your virtual machines. GKE is Google Container Engine. I think it's because the C was already taken. So this is the management of the Dockerized containers. And GAE actually refers to three different things. So you want to make sure that when you're looking at GAE, the sandbox is the version that's been out for years and years. Endpoints is what's used with mostly Android development, but it's a general set of middleware, if you will. And managed VMs are the new version of App Engine that works with Docker, but is not Container Engine. So a little bit tricky. So I actually pulled this together in a grid as well. If you're looking for a virtual machine that you manage, you're going to go with Compute Engine. So it's infrastructure as a service. Do remember to look at the click to deploy depending on what it is that you want to set up. And we use the example of WordPress, but there's a whole bunch of images there, which is, again, analogous to what other vendors call AMIs or virtual machine images. So it's under the click to deploy under the deployments section. Again, it's really easy to forget that it's even there because it's not under the compute section. And you can really save yourself a lot of time if you're setting up a standard configuration. And you can use that as a basis for creating virtual machine images as well. If you want to work with a containerized or application virtualization, you have two options. You have Container Engine, or you have App Engine Managed Virtual Machines, which is a flavor of App Engine. As of this recording, both of these services are in beta, so be sure to check the Google documentation when you're using those. And I will also mention that their implementation of containers or Docker includes the management service called Kubernetes. If your solution calls for compute that has application virtualization that's more completely managed by Google, then you'll be using the traditional App Engine, which they call Sandbox, or App Engine endpoints for specialized usage like infrastructure, particularly for Android. Now, one thing we did not cover in this section, but we'll cover later in this course, are other services that are traditionally associated with compute. And these are networking, deployment, and monitoring.